Good evening, everyone. Thank you very much for having me. My name is Roderick Darling, and today I'm going to speak to you about some research I conducted last year whilst I was studying my Masters of Structural Engineering at the University of Melbourne. So my topic was damage to infrastructure caused by the impact of hail. 1/3 of all insurance claims are a result of hail damage, and currently in the Australian standards there is no provision for designing hail resistance. And so my research looked at filling this void and providing a possible solution where you could design to mitigate some of these damages that are caused. Tonight I'd like to, in the 10 minutes I've got, give you a brief overview of how hail is formed. Then I'd like to give some examples of hail damages and run through how the damages do occur. And finally, I'll give a very brief overview of the method I developed for designing the hail resistance. So, how does hail form? Hail form is hail is a type of precipitation which is pushed up by an updraft above the freezing point in the atmosphere. Once it gets above this point, the moisture in the air will freeze and it floats around and connects with other frozen particles, and eventually hailstones are formed. These hailstones grow until they are heavy enough to overcome the updraft and they fall back to Earth. There are a number of factors that contribute to this, which I've listed here: low level moisture, atmospheric instability, mountainous geography. Mountainous geography is important because if you have a horizontal wind, it can come into contact with the mountain and it will push up, create the updraft, and then you form hail. Changing wind directions, again, that can create updraft. Height of the freezing level. This is very important. So depending on where you are and the time of year, this height of the freezing level will vary towards, I've said here, late spring and early summer. So by the end of winter, the atmosphere is cooler, the freezing level is lowered, so you require a less strong updraft to push the hail above that freezing point. Or, if you have a strong updraft, the hail will remain above that freezing point for longer and will grow larger. And convective activity. It's in the mid-latitudes, for a number of these reasons, that we have the most hail formation. Is a map of Australia. So this is the 30-degree line here that shoots across there. So we have Perth, Adelaide, Sydney, Melbourne, and Hobart all that fall within this 30 to 50 degree bracket. So now I'd like to talk to you about some of the damages caused by hail. As I said in my introduction, 1/3 of Australian insurance claims derive from hail. Of the damage that's caused, 80% comes directly from the impact of hail. Breaking windows, breaking roof tiles. The remaining 20% is from water damage. So often you'll have a broken roof tile which will then lead to water ingress and create structural damage to the building. Bureau of Meteorology will release an extreme weather warning when hail is greater than 2 centimetres. This is similar to what happens in the United States and in Canada. Australia, we've been fortunate, we haven't had a fatality caused by hail. We often have injuries that are reported after major hail events, but globally there are a number of fatalities that occur every year. Between 1982 and 1989 in India they had 250 fatalities alone caused by hail. So it can be an issue, but in Australia we're fortunate we don't have that many people that work outside, and obviously the population is much smaller than India, so we are less likely to have these fatalities. As I also mentioned, the Australian standards don't provide provision for designing hail resistance. My theory is that if we had casualties in Australia, hail would be taken more seriously, and likely we would have provisions like we have for earthquakes and fire and cyclones within the standards. So I've got some images here of a hailstorm that occurred in 2010 in Melbourne. Wouldn't want to get hit by one of those hailstones on the head. I think it would do a bit of damage. Here, this is Southern Cross Station in Melbourne, where it was relatively new at the time of this, and there were skylights, and during the storm, water pondered on top of those skylights, and they were eventually broken by the hail, and here we can see the water gushing through. Now, to ensure that this presentation wasn't entirely focused on Melbourne, I did a Google search and found a Perth hail event, again from 2010. This one did over $100 million worth of damage. Both these images are from the University of Western Australia, and it's pretty clear that a fair bit of damage has occurred. Now, hail has been looked at previously in research. A number of people looked at the mechanics behind hail falling, and others have focused on quantitatively trying to estimate the amount of damage that will occur in a hail event. And this is really for the benefit of the insurance industry. No one has focused on trying to mitigate the damages that are caused by hail. So I'm going to use an example which I used as my research, which is the old engineering building, and I will show how you can design here for hail resistance. So the first step is to identify the elements that are going to be most vulnerable. So here it'll be the windows and the roof tiles. Now there are a number of steps to step through, and I don't have time to expand on these steps, unfortunately, but first thing you do is determine your maximum hail size that can occur. This is relatively easy to do in a city where there's lots of data on hail sizes, and you can generate a return period. And so that's what I did in this case, looked at Melbourne data for hailstones, generated the return period, and I used the 100-year return period here, which gave a maximum hailstone size of 11.4 centimetres. Next is you determine your hail weight. That's relatively simple. Horizontal velocity. If you were going to look at a skylight, you'd do vertical velocity, and that calculation is fairly simple. Horizontal velocity is a little more involved. The Australian standards assume that within the wind code, that items thrown from rest, this doesn't apply to hail, which is already in the atmosphere, and so it will be travelling at the average wind speed and then will be accelerated by the 3-second gust. So that's what you do here. And as the hailstone grows, that acceleration effect is diminished. The next alpha term is the ratio between the mass of the impactor and the target. And then the next step is to determine the equivalent static force. This I used an equation which was established by Nelson Lamb, Professor Nelson Lamb at the University of Melbourne, which accounts for rebounds, which occurs when there's hail. Obviously the hail bounces back, and the mass of the two structures that are colliding. Then you get deflection, and finally the most important thing is you get this moment per unit length. So from the moment per unit length, you can then go to the Australian standards, where the Australian standard for glass has this equation here, with RU is the moment per unit length. There are a couple of important factors here, C1 and X in particular. So C1 is the type of glass, and X is the geometric factor. So by changing either the type of glass or the geometry of the glass pane, either its thickness or its size, you can increase the resistance to hail impact. There's a sweet spot where the glass will be its strongest, and above, its weakest, and above that, as you keep increasing the size, it becomes stronger again, because the mass of that glass will be a stronger target. Finally, there's a limitation to this method in that punching failure could also exist. So the failure mechanism that I've covered is one of deflection, which can be done theoretically. Punching, you would need to really focus or do experimentally. It's much more complicated from the mechanics side of things. And that's everything. Thank you very much. Any questions?
Yeah. Looking at damage, typical damage from hail for glass, for example, is it usually a deflection failure or a punching failure that causes a window or a large pane of glass?
So usually in buildings, it's deflection, but on cars, it's puncture. So the two are valid failure mechanisms, and if you were going to have a standard, you would want it to cover both, so you design for both. But you really would have to run experiments. You'd want to run experiments to validate this as well, but to actually develop a model of designing for puncture, you'd want to run experiments. Yep.
So what's the next step now that you've done this research and developed this method? What have you done next with that information?
So the professor who was my supervisor while I was doing it has now handed this on to a PhD student who is going to run these experiments and hopefully validate what I've done. And then from there, hopefully at some point we'll have it incorporated in the standards and the damages will be reduced.
So the proposed solution is something like changing the geometry or changing the type of glass? Is that what the solution is?
Yeah, so in that example, if you took a 1 metre by 1 metre pane, which was 8mm thick, it would fail. But if you changed the glass from a normal glass part to a toughened glass, it would pass. So it's more about knowing, okay, in this situation this glass would fail, but I can make certain adjustments and it won't be a risk any longer. But at the moment, it's just the thumb sock whether or not the glass pane would resist glass or otherwise resist hail or otherwise. Yep.
Some of the damage to the University of WA was the stained glass windows, which were quite old.
Yeah.
How can you actually solve that problem?
Well, I don't think there's much you can do about retrofitting unless you want to go back and replace each of those little stained glass windows with toughened glass. But it's more about designing for future construction. And I guess if you were to go back and replace those stained glass windows, which they would have had to do, you could apply this knowledge as well.
But if you put a clean sheet of glass in front of it, that would protect it?
Yeah, definitely. You could do that. That would be an aesthetic consideration. Aesthetic? Yep, sorry.
So you've done sort of 100-year, maximum 100-year size house. Where would you see the standard being set to? I mean, I think the climate change, we are expecting larger hailstones to be working for the standard to accommodate for the 100-year record, or looking for larger than?
Yeah, that's a really good question. So someone else at Melbourne University also looked at exactly that. And the conclusion of that research was that the frequency of hail events won't actually increase because it will be offset by warmer temperatures, which will then increase the height of the freezing level. You will have more variability. So you're increasing one factor and decreasing the other, and hail events shouldn't increase. So you shouldn't have to future-proof as such the designs. You can just design for now and assume that it will be constant in the future. Yep.
I'm a bit concerned about the economic implications of these changes. Because you were very clear at the beginning, it's about insurers, insurance companies. If you make glass thicker or metal sheets in cars thicker to withstand hail, they will be heavier, more expensive. Structures to support, for example, this glass greenhouse we saw in UWA, to support heavier glass, you need a better structure, which in turn is again more expensive, probably more pollutant during manufacturing. You know, there's like a chain of costs associated to implementing all this. And the reason of being of insurers is to pay for these things, you know. That my question would be, how often these things happen? So how often Melbourne has to pay $900 million in damage every how many years?
Well, it's a third of insurance claims annually.
Annually.
But you could assign an importance level where for a greenhouse you might say, okay, well, we're willing to put glass to break, but in this other building where water ingress would be more of an issue and might cause future structural issues, we don't want the glass to break, and therefore we'll design in that case. Yeah, there will be considerations of glass being heavier and whatnot, but I guess that will come down to the owner of the building making the decision. But currently there are no tools that you can make that decision with.
Okay.
Time for one last one.
Did you looked at glass, did you actually look at roofing materials?
No, I didn't look at roofing materials. The method would be the same. It would just be a matter of going and applying the factors for the roofing materials. Up until that final step where I had the glass coat, you get your moment per unit length, and presumably if you had a roof tile, you could then go and there'd be some code or somewhere you could look up and determine whether that would break given a roof tile. But I didn't look at it, no.
Thank you very much. I think our speaker again.